But if you're not aware of that, encapsulated ingredients have been used in the market in the industry today for about 30 years now. Sodium bicarbonate, sodium chloride, fumaric acid, citric acid have been used widely in the industry in your bacon industry. If you look at it, sodium bicarbonate, the two biscuits that are out there in the market made by Pillsbury, they actually use an encapsulated chemical leavening plant. Therefore, when the product cooks, the coating melts off, creates CO2, causes it to rise. Encapsulated fumaric acid is used in tortillas that helps reduce the pH of the product, makes the calcium bromate work, therefore it becomes a mold inhibitor. So there's a wide range of ingredients out there to use, but nobody knows about them. If you look at the ingredient declaration, it does not say encapsulated ingredients. So what I'm sharing with you is they've been out there for quite a long time. So from that particular slide, you have a sample of fizz. I want you to take a little bit, put it in your hand, put it in your mouth, lick your fingers.
Don't.
I'm sorry, we don't have any water for you.
Just fizz more.
A little exciting now. So what I'm trying to say is encapsulation delivers innovation. Effervescence controls the chemical leavening. So you tasted a sample of encapsulated citric acid, you tasted nothing but citric acid release. At the same time, what you have done here is you have taken a combination of an acid and a base, you put them in your mouth, and with, basically you have the water or the saliva of your mouth start to react to the ingredients, create CO2, therefore the carbon dioxide starts to release. That's what's going on within a bacon application. Once you introduce a chemical leavening that is not encapsulated, you start that CO2 reaction, and therefore you basically have some proofing going on. So what I'm saying is, how do we control that certain situation? So what I'm going to show with you is, as the director of IFT, as I am the process development director for developing encapsulated ingredients. And this particular picture is a picture of raw material sodium bicarbonate. So basically, sodium bicarbonate looks like broken glass, and therefore encapsulation is surrounding individual particles. Therefore, the process is separate an ingredient from its environment until it releases from an interaction that's desired. So basically, how many are familiar with encapsulation or have heard of it? So basically, this is a fluid bed encapsulator that we use at IFT. Basically, this is a 500 kilo machine that we use to produce our particular products on it. If you're not familiar with it, an example of citric acid it gave you, because even my kids, as they're growing up, they're saying, "Dad, what do you do besides make money?" And I said, kids, the only way, best way I can describe it is that encapsulation or using this process, because I've been doing it for 20 plus years, is that somebody's standing on top of a ladder, they have a can of spray paint, and basically you're going to throw a rock up in the air, and you're going to continue to spray paint that rock until it gets coated. So you're going to continue to throw it up and continue to throw it up until that rock gets entirely coated. Therefore, you will not see the core. Therefore, that's the situation of what you tasted in the encapsulated citric acid. Therefore, remember the raw material sodium bicarbonate? This is what a sample of encapsulated sodium bicarbonate looks like. But for my particular application, I actually took to the next step is I actually put the sodium bicarbonate, sodium aluminum phosphate, I fused the two together and actually encapsulated them to create the picture on your right-hand side. So therefore, you have your acid and base together. They are the marriage, they are together. They're coated together, so when the coating melts off, they have the water, they have the heat, they create the CO2 to create the chemical leavening. So we'll get to that in a minute here. So here was my optimized pizza crust recipe. Started adding and basically very different things and portions and so forth, but basically I added encapsulated the bakery blend, dough relaxer. I did add yeast because I love the flavor of yeast. If you're having a dough product, you just don't want something tasting like cardboard, so a little bit of yeast makes a great flavor. So again, what I'm showing here is demonstrating the encapsulated ingredient. Even though you bit into your particular samples, when you're using the encapsulated ingredient, it's protected by a shell. So the blue layers are showing you have your sodium bicarbonate, you have your sodium aluminum phosphate, It's protected from oxygen, water, heat to its desired temperature that it needs to release. Therefore, it's protected. So I have to design a melting point that's going to use in that particular baking application. So what I'm saying is, things are going to bounce off. They're not going to react. Once you put it in, this allows the control and consistency of releasing the chemical leavening. You can see the layers of the coating material start to release as the heat comes in contact with the coating. The water comes in contact with the leavening agents. Therefore, CO2 begins to take place. Therefore, the chemical leavening begins to rise. Therefore, it gives you consistent leavening time after time. Now, for my experimentations, that's why Cesar, with his calling this book "Kitchen as a Laboratory," is great, because all my pizza crust I hand rolled out. You know, we don't have a pizza sheeter. Therefore, all my experimentations, all my work was done in my kitchen. So it was great. So therefore, you know, I'm hand rolling out things. If you take it to sheeter pizza place, they got perfect pizza things, slice right in, give you the perfect crust every single time. So I'm not saying my crust is perfect, but at the same time, it gives you that nice, even chemical leavening. So here's a picture of my first attempt. When I started playing with encapsulated ingredients, I actually added so much it turned into pizza bread. So you can see this thing I swear was like 3 inches tall. So, but basically, as you can see here, I started getting it under control. So if you do buy the book, the recipe is inside the book. You can see the pizza crust rising. I didn't put any toppings on it. You can see the final one on the bottom right here. But here you actually see on the bottom is just using Mom's recipe as yeast, as a low rising pizza crust. Using my recipe with the encapsulated chemical leavening, you can see, which is the picture of the top crust, where you can see how much higher it rose by using the encapsulated chemical leavening system. What I'm showing you here is not to pick on pizza crust, but the thing is that using encapsulated ingredients, when I make homemade pizza using my ingredients, is that the situation is I make all the crusts as fast as I can, put them in the refrigerator. When it's time, you pull them out, you can roll them out, you can use them whenever you want. What I actually did here is to demonstrate here is that the one on the far left is my mother's recipe. It actually sat in the refrigerator for 48 hours. It had some rise to it, but it had an awful smell. Alcohol, yeasty smell. It could even started growing mold as far as I know. But it did give some rise. The one on the right-hand side is using chemical leavening. The chemical leavening basically says the water exhausted it, there was no more CO2, so when you baked it, it turned into a cracker or Minnesota pizza. And then in the end, by using the encapsulated chemical leavening, actually it gave the perfect rise to the crust. It gave uniform crust. So what I'm showing you here is this crust, these crusts actually sat in my refrigerator for 48 hours before they were baked to give you some aspects to it. So this is the final product, and actually you can see here, you can see how the crust here gives the same height all the way across, and that's what I'm talking about, uniformity across the particular crust. I wanted to take this picture to show you guys that even hand rolling out pizza, you were able to get that same rise straight across instead of the weight of the pizza crust falling down. Therefore, you can see the bottom ones, my son's on my pizza crust, and at the same time we put 5 pounds of toppings and we still got rise to the pizza crust. So the thing is it's great. It's a great ingredient. So what I want you to do is say, make it your own style. We have New York style, we have Chicago style, we have California style. But in your bag, I've given you a sample of encapsulated bakery blend for you to take home. So if you do have a homemade pizza crust and would like to try it, use 2.6 grams for a pound of dough or 500 grams of dough. And so use 2.6 grams, about 3/4 of a teaspoon, and try it and give it a whirl. You also have a sample of dough relaxer. You may not need to use it, you may need to use it. Because sometimes dough relaxers, when you use encapsulated, it creates the CO2, creates the gluten. Well, if there's nothing in there, the glutens form tight, therefore the dough may be difficult to roll out. Therefore,